So coefficient of variation, people call it C, makes sense as to why. It is a simple formula, S over X bar multiplied by 100, and it is a percentage. Now, we know S is the standard deviation and X bar is the mean for the sample. Sample standard deviation, sample mean. So when to use this, what is the purpose? The purpose is to compare two samples and get a quick idea as to, what's happening in the two samples. But we can directly compare two samples using a histogram by finding the mean, standard deviation, and so forth. So we use the coefficient of variation to compare two samples when they have significantly different means. For instance, if one sample has a mean of 30, another sample has a mean of 80, then, comparing the variation directly is not a good idea. The second case is when the samples are measured in different scales. What do we mean by different scales? As an example, straightforward example, age. How do we measure age? That's an easy question. Time, specifically. Years, right? In years. And let's say hair length. How would you measure that? Inches, or if you're proper, centimeters. Yes, so this scale and that scale are entirely different. Do we agree? But if I want to directly compare the variance of this sample against the variance of that sample, the better approach would be to use that. Numerically, they might be significantly different. Of course, you may say, well, if one is in inches, if one sample is in inches, the other is in centimeters, I could do a direct conversion after I search in Google on how to convert inches to centimeters. Sure, but that's extra time, right? So you could find CV directly and come to a conclusion. Does that make sense? So two cases when we typically use coefficient of variation to compare samples. One, when their means are significantly different. Two, they are measured in different scales. Are we clear? Okay. So hopefully guys know how to find the mean, standard deviation. What is the mean and standard deviation for ages? Standard deviation.
85. Oh, sorry, standing 3.529.
So the question often comes about, rounding. In general, the more decimal digits you have, the better it will be.
The standard deviation is 3.5.
Oh, 3.53.
I mumbled.
So what was I? Rounding. So typically, the more you have, more decimal digits you have, the better it would be. So if you're finding sample statistics such as mean, standard deviation, I recommend 2 decimal places. If you're finding probabilities, which we will do later, 4 decimal places. So the coefficient of variation is 3.53 divided by 26.3 multiplied by 100 to get it as a percentage. And what does that equal to?
13.42.
So what is the mean of the second sample?
85.3.
85.3. The standard deviation,
25.49.
25.49.
Yeah, or 0.49.
0.49. So how do we find the coefficient of variation?